Hello, greetings. My name is Miro Kuchibuza Marcel, and I'm the founder and the director of the Pan African Citizen Science eLab. So today, I'll be taking you on a lecture to the stars. This video is made possible through the Free Astro Science in collaboration with the Pan African Citizen Science eLab. So today I'll be taking you on lunar phases and eclipses. These are two wonderful astronomical events that everyone on Earth knows about. So in the table of content, I will be explaining what makes the moon shine at night. I will be explaining the science behind why the moon shines at night. Then I will now introduce lunar phases, and I also explain why don't we experience eclipses every month. Then I'll talk about the solar eclipse, the lunar eclipse, then some special lunar events. So, what makes the moon shine at night? And a simple answer is reflection. In the same way, a mirror, a light reflects from mirrors from polished surfaces the same way your face reflects off from mirrors of mirror if you're facing a mirror. This is the same way light is being reflected from the from the from the moon. The light from the sun is being reflected off from the moon. So the sun emits radiations, it emits um, light, and the light hits the moon's surface, which is made up of rock and dust. Okay, now unlike a polished surface that reflects most of its light, the moon only reflects 12% of the light that is incident on it. So that is why we can see it. So the moon's surface reflects some of the sunlight back to Earth. So look at this picture here. You can see the sun emitting radiation, and here is the moon, and here is Earth. This is the nighttime, and this is the daytime. So when you see the moon at nighttime, it is oriented in this position, somewhere in this position, so that when radiations from the sun hits it, it gets reflected, and the people in the nighttime see it. So that reflected light is what we see from Earth. It makes the moon appear to shine. So the reason why I'm mentioning this is some people haven't really gotten the picture of how this whole thing is structured. Okay, because some people still believe that the earth is the universe and everything and all the stars we see at night are inside earth. So from this picture you can see that earth is just a finite spherical shape as well as the moon, and the moon is just trapped under earth gravity and it is revolving around earth. So that is why, so they are just separate bodies. If if not because of gravity, they would have been to their separate ways. So here's the picture of the moon at night as we see it. So now on the introduction to lunar phases. Now I want you to know that at any given time, half of the moon is always illuminated. Although this is going to be very hard for you to believe because you don't always see uh, uh, you don't always see it, but we're going to explain why this is so. So, because our viewpoint on Earth, we don't always see the entire lit surface. Do you understand? So that is why we experience lunar phases, and I'm going to explain that. So, but from this picture, you can see that half of the moon is lit. And I'm going to explain why it is not so with us. So here is a simulation or animation of lunar phases. So you can see the sun, here is the earth, and here is the moon revolving around earth. Okay, and you can also notice that half of it is continuously or always illuminated by the sun. But from our own perspective, we see phases. We see phases here. And the reason is because of the moon's position. is the moon's position relative to Earth and the sun. So, and that will bring us to the lunar phases, to the different lunar phases. There are several lunar phases. I'm going to start from the new moon. So, during the new moon, you have the sun, you have the moon somewhere between the sun and the earth, somewhere between, not perfectly in alignment. Just note that. So that now you can see that the radiation from the of the sun is hitting this side, but we cannot see it from our own side. Okay, so here is the kind of thing we see. In fact, we haven't even seen a new moon before. No one has ever seen it because it doesn't reflect sunlight. Okay, so so at this point, even a solar eclipse can occur. This is the kind of condition that creates a solar eclipse, but we do not experience it on every new moon. Okay, so the reason why we do not experience it on every new moon is because there are two ingredients that is required for eclipses to occur. All kinds of eclipses, there are two ingredients. So one of them is this kind of arrangement where you have the sun, you have the earth, and you have the moon between them. So, so that is not sufficient. So there's another ingredient that is required, which I'm going to explain further in this lecture. So just stay focused. So here's the second lunar phase called the waxing crescent moon. The waxing crescent moon. So at this position, the moon has moved a little bit out from its new moon phase, and also observe that half of it is still light, but then we can see a small portion of it, like this portion. For those that are facing Earth, whether you are in the nighttime or in the daytime, you can see a small portion of it. So this is kind of thing we can see, okay, because of the way it is now facing, the position it is relative to Earth. So waxing means increase. So it means the increase in the brightness of the moon. So it occurs between it occurs between 1 to 6 days into the lunar cycle. So here's an example of a waxing crescent moon. Then we have the third one called the first quarter moon. The first quarter moon. So now the moon is now 90 degrees from the sun in the sky. So relative to Earth. So here is it. So you can also see that half of this of the moon is late, but we can only see 90% of it. So the right half of this, well, the right half of the moon is illuminated. So some people commonly call it the half moon, the half moon, but the the real professional uh, term for it is the first quarter moon. So this first quarter moon occurs between 7 to 8 days after the new moon. So here's an example of the first quarter moon. Then we have the waxing gibbous phase. The waxing gibbous phase. Now the moon has moved a little bit out from the first quarter. So here it is now more than half of its illuminated surface, but not yet full. So it occurs between the first quarter and the full moon, and typically occurs between 8 to 13 days into the lunar cycle. So here is the kind of thing we see from uh, what we see from the waxing givers. By the way, I've explained what waxing is, means increase. Givers means spherical, it means over. So waxing givers moon means the moon is increasing, the oval shape of the moon is increasing in brightness. So that is exactly what it means. Then okay, this is the picture, example of a waxing gibbous moon phase. Then we have the full moon, okay, which is about 100% of the moon's visible surface is lit as seen from Earth. So you can see it from here. So the moon is between the sun and the Earth is between the sun and the moon. So the entire side facing us is fully illuminated. Okay, so so this full moon is actually the brightest phase of of the lunar cycle, the brightness. Okay, so at this point, at this point, for those that still remember their their physics background or what the teacher taught about eclipses, there is a possibility of an eclipse happening when you have this arrangement, when you have an arrangement of the moon, earth, and the sun. And that kind of eclipse is called the lunar eclipse. However, anytime, not all the time that you have this kind of arrangement that you have a lunar eclipse, okay? Like I said, for solar eclipse, there is one more ingredient required for you to have a lunar eclipse, which I'm still going to explain further in this lecture. So we have the waning gibbous phase. At this point, the moon is closing back on its brightness. So it is almost like the opposite, not almost like opposite, it is the opposite, or should I say the mirror image of the waxing gibbous phase. So we are talking about the waning gibbous phase. So the moon has started to close on itself, and this typically occurs between 15 to 21 days of the lunar cycle. So at this point, the moon begins to shrink and light appears to decrease from the right side. So you can see it from here. So here's an example of a waning gibbous phase. So you have the last quarter, like just like we have the first quarter, we have the last quarter. Some people also call it the third quarter. If you call it either the third quarter or the last quarter, you are very correct. So it is just like the mirror image of the first quarter. Okay, so some people just like the first quarter, they still call it the half moon, and this occurs between 21 to 22 days into the lunar cycle. Then here's a picture example of the last quarter, and now we have the waning crescent moon, which is the mirror image of the waxing crescent moon. So it is the final phase before the cycle restarts with a new moon, and occurs between 23 days to 29 days of the lunar cycle. So here's a picture. So and after that we have another new moon. Okay, and the whole thing continues. So from new moon to new moon is 29.5 days. It takes 29.5 days approximately. Okay, so and that is 1 month. That is 1 month. That is how we define 1 month. So here is the summary of the all of everything I've talked about lunar phases. So in summary, we have 4 primary phases and 4 intermediate uh, phases. Okay, so for the primary phases, we have the new moon, we have the first quarter, we have the full moon, we have the last quarter. Then for the intermediate phase, we have the waxing crescent moon, we have the waxing gibbous. Okay, and we have the waning gibbous, and we have the waning crescent. So here is a video simulation of what I've just demonstrated. Let me make it to start from the beginning. Okay, so you have the full moon right now, and now the moon will begin to close in on itself. Okay, begin to close in. Remember, it is half. It looks like half of it is illuminated, but we can see the phases here. So here's the sun right there. So we're gonna have a new moon right now. We're gonna have a new moon right now. So you can see that. You can see it on the new moon. And now the moon will begin to open again, and we have the waxing crescent, we have the first quarter, we have the waning, and now we're going to have the full moon. So that is how it continues. That is how it has been for billions and billions of years ago. So now remember that I talked about alignment, kind of an arrangement between the sun, the earth, and the moon being here and also being here. Okay, so now if the alignment of the sun, the moon, and earth causes new moon and full moon, so why don't we experience an eclipse every month? So that's a very nice question. Some people might want to ask, why don't we experience it? We are supposed to experience it every month because during the new moon, we have the moon between the sun and the earth, and during the full moon, we have earth between the sun and the moon, and the shadow of one ought to cast on the other. So now, and I give you this picture. So this is the top view. Top, if you look from it from the top, this is the a simplified version of our solar system with only the sun, the earth, and the moon. Okay. So, but if you look at it from sideways, this is exactly what is going on. This is exactly what is going on. So you can see the moon goes up at some point, like relative to Earth, it goes up, then comes down. So it doesn't act, it doesn't move like this. So so it is not that it is moving like a circle. It is not a circle. This is an elliptical orbit. Okay, it is not a circle. Assuming it is moving at the middle, like it is moving like the way we thought it was moving before, then we might be having eclipses every day. So the reason why we don't have eclipses is because the moon is tilted, and that angle that it is tilted is 5 degrees. So eclipses only occur when the sun, the moon, and the earth align closely along the same plane, called the ecliptic node or plane. So I have given you that second ingredient right now. The first ingredient is that there should be an alignment, okay, probably during the new moon or the full moon. And then the second, which is they should be in the same plane called the ecliptic nodes. So during these other months without eclipses, this is exactly what you experience. So here you see the shadow of the moon trying to cast. Sorry, not trying to cast, but here is the shadow of the moon, but it has mixed Earth. This is the shadow that causes the eclipse. What we call eclipse is just simply shadow casting on the other one, celestial body. So that is exactly what we call the eclipse. So since it is the moon shadow is missing Earth, there won't be eclipse. But assuming that they are in the same plane, like in the same plane like this, then there will be eclipses every month. But because of that, we have to wait for when there is an alignment in that node. So we call that the ecliptic node. So here's that node here. So when the moon comes to this node, when it aligns to this node, we have either a solar eclipse or a lunar eclipse. So here's another picture of the node. So here are the times we have favorable and favorable period of eclipses. So here is just ordinary months that we don't have eclipses. So you can see the different shadows. See, this is doing new moon, this is doing full moon, and here is the Earth. So no eclipse. So only occurs when the moon is at that node. So now let me now dive deeper into solar eclipses to explain them further. So solar eclipses happen when the moon passes between Earth and the sun, casting a shadow on Earth and blocking all or part of the sun's light. So this occurs only during a new moon. I can't stop emphasizing that. So the alignment must be precise. Okay, the sun, the moon, and Earth must align in a straight line. So they must be in a straight line. So before an eclipse can occur. So now for eclipse, we have solar eclipse and lunar eclipse, like I talked about. So for solar eclipse, we have two kinds of shadow. The moon casts two kinds of shadow towards Earth. We have the region called the umbra, and we have another region called the penumbra. So the umbra is the darkest part of the shadow of the Earth, the darkest part during the solar eclipse. So where the sun is completely blocked. If you're in this path, it is the sun's radiation is completely blocked, and you can literally remove your eyeglasses that is protecting you. You know, you're not supposed to look at the sun during eclipses, but during this few moments of the umbra, if you're under the umbra, you can literally remove it and nothing is going to happen to you. So if you are here, you will see what we call a total solar eclipse. It's one of the types of solar eclipse I'm going to explain. Then we have the penumbra, which is a lighter outer shadow. Only part of the sun is blocked. So then you're going to see a partial solar eclipse. So, but note that both the umbra and the penumbra move from the move uh, move and form a path called the path of totality. So here's the picture of the sun, the moon, and the earth. So here's the shadow of earth showing the penumbra and the umbra. So here is the umbra. So here's the penumbra. It's usually larger than the umbra. So here's the picture taken by the astronauts on the ISS. They were lucky enough to capture this moment. This is a very rare moment. So they captured the lunar eclipse. Here is the umbra of the moon on Earth. So types of lunar eclipses, we have three types of lunar eclipses. We have the total solar eclipses, and we have the partial solar eclipses, and we have the annular solar eclipses. So for the total solar eclipse, it occurs at perigee. Remember, perigee is the point at which the moon is closest to Earth. Okay, the apogee is the point at which the moon is outer to Earth. So when the moon is closest to Earth, we have what we call the total solar eclipse. So at this point, the sky goes completely dark. Stars may appear. You might see stars towards the direction of the sun, meaning at the background of the sun. In fact, that's the total solar eclipse was used to prove Einstein's general theory of relativity, where he proposed that gravity bends the fabric of space-time. So this eclipse was used to prove his theory. So during this time, if you want to see the solar corona, the corona from the sun, it is very gigantic. You can see it during this total solar eclipse, but it only lasts for few minutes. The longest solar eclipse ever recorded lasted for just 7.5 minutes. Okay, and it moved through a path called the path of totality. Then if you happen to miss, uh, or maybe if you're unlucky to not be in the path of the totality, you might then witness the partial solar eclipse. So total solar eclipse goes with partial solar eclipse. Okay, so the moon at the partial solar eclipse, the moon covers only a part of the sun. Okay, so but it's gonna look like you're gonna feel it because the weather, the conditions of the atmosphere of the environment will not look that bright. Okay, so it is visible over a wider area than the total solar eclipse. And what happens when you are in the penumbra? Then we have this particular kind of solar eclipse called the annular solar eclipse, which occurs when the moon is at apogee, when it is further out from Earth. So at this point, it forms what we call the ring of fire, or called the annulus. So the path of these, just like we have the path of totality for solar eclipse, the path through which the annular solar eclipse passes through is called the path of annularity. If you compare annular solar eclipse to, to the total solar eclipse, annular has been more frequent than total solar eclipses. So here's the red diagram showing the annular solar eclipse and the total solar eclipse. So here's the red diagram. So you can see the dot of the total solar eclipse pointing towards Earth. So you have the umbra, you have the penumbra. So for the annular solar eclipse, you can see that there's a kind of a crossing of the rays of light because it is farther out. So there is a rare kind of eclipse that combines both the solar eclipse and the total solar eclipse and the annular solar eclipse. We call it the hybrid solar eclipse. The hybrid. So it happens due to Earth's curvature and the Moon's distance. Hybrid eclipses occur only a few hours per few times per country. So here you can see the Earth. You can see the red diagram during annual eclipse. Okay, it crosses because it is further out because at this edge. If you compare this edge to here, it is further out from the moon. So there's going to be kind of a crossing. But then as the moon moves, it's going to come into a higher ground like here. So those crossing will cancel out. So we have a total solar eclipse. And when the moon continue moving, we're going to have an annular solar eclipse again. So we can have this kind of situation. So imagine that this is happening. Okay, some people over here are reporting that we saw annular solar eclipse. Some people here are reporting we also saw annular solar eclipse. What people are here are saying we have a total solar eclipse. So watch out for that during any eclipse announcement, any total solar eclipse announcement, so that you get assuming that it crosses across different hemispheres, so that you can check distance. So hybrid eclipses only occur a few times per century, like I've said before. So here's the map of solar eclipse forecast since 2004 to 2030, even in the future. So here is the path it has moved. This is Africa. That's moved through this path. Sorry. It has moved through this path. It has also moved through oceans. You see. So this is it. Now, assuming that you experience, assuming you experienced eclipse when you were younger, or maybe you haven't experienced it before, and you're curious. Oh, when am I going to experience eclipses? I want to shock you that first of all, solar eclipses happen somewhere on Earth between, every 18 months. But any one location may see total solar eclipse once every 300 to 400 years. So it means that if you have experienced, if it has passed through your country in the past, maybe 50 years ago or 100 years ago, you have to wait for 300 to 400 years before to pass through your country again. So anytime you hear about eclipse passage announcement, take advantage of it. See it as an opportunity of a lifetime to go out and witness a very rare astronomical event. So we have the lunar eclipse. We have the lunar eclipse. So the blood moon, people call it the blood moon. So the lunar eclipse occurs when the Earth passes directly between the sun and the moon, and that is going to cast its shadow on the moon. So this only happens during a full moon, where the moon is on the opposite side of Earth from the sun. But unlike the solar eclipse, the lunar eclipses are visible from anywhere on Earth where the moon is above the horizon. This means millions can view it at once. So here is the physics behind the lunar eclipse, because some people haven't really quite uh, assimilated these things. No, they'll still, you know, use some mystical. People are superstitious, so they still believe it is not normal. It is not a normal thing. Okay, so here you see the sunlight passes through the Earth atmosphere. Okay, so the short wavelengths like the uh, blue light is scattered, just like we have during sunrise and sunset. Okay, so but the longer wavelength is going to pass through the longer wavelength like red and orange. They're going to pass through and they get refracted through Earth atmosphere, and that reflected ray is incident on the moon surface. So we see the blood moon. So that's just the physics of it. So we have types of the lunar eclipses. We have the total lunar eclipse. We have the penumbral lunar eclipse. And we have the partial lunar eclipse. In the total lunar eclipse, the entire moon passes into Earth umbra. So no direct sunlight hits the sun, and the moon glows red. We call that the blood moon. Then we have the partial lunar eclipse, so only part of the sun enters the umbra. A section of the moon appears beaten or darkened. Then we have the most subtle of them, which is the penumbral lunar eclipse. Nobody actually ever knows when this is happening. Okay, and it's not even interesting because you're not going to see anything. So moon passes through moon passes only through the penumbra. So there is a subtle dimming, hard to detect without an instrument. You need to instrument to even detect it. So lunar eclipses can last for several hours, but total eclipses that lunar eclipses can last for several hours, with totality lasting up to 1 hour 40 minutes. So here's a diagram summarizing everything I've talked about the lunar eclipse. So here is the sun, here is the earth, and here are the moon positions during this period. So if the moon enters this region, the umber region, umber shadow region of the moon, it experiences a total solar eclipse. If it is somewhere in between that region, that is umbra, and the penumbra region, we call it a partial lunar eclipse. So, but if the moon is entirely in the penumbra, it is nobody takes it seriously, okay? Unless maybe you are interested in research or something, but it is not always very interesting. So that is the moon being in the penumbra lunar phase. So here is the regular full moon in comparison with these other ones. So special lunar event. So we have the supermoon. The supermoon occurs when a full moon or sometimes new moon coincides with the perigee. Okay, so at this point, the moon appears 14 times larger and 30 times brighter than a regular full moon. So super full moons typically occur between 3 to 4 times per year. So we have the micro moon, okay, a full moon or a new moon that occurs near apogee. So the moon farthest point from Earth, okay, which is the apogee. It appears smaller and dimmer, which is about 14 to 12 to 14% smaller than the supermoon. So it is not easily noticeable to the naked eye unless compared in astrophotographs or in the photographs. So there's a phenomenon called the Earth shine. Earth shine. It's a very interesting phenomenon during new moon or crescent phases. So a soft, faint glow of moon's dark side during the crescent moon. It shines. So here's the physics. So you have the radiation from the sun. I mean, sun is illuminating everything. So it hits the surface of the earth, maybe hits the ocean in the daytime. In the daytime, okay, hits it, and water is 70% of Earth, and it reflects light a lot. So that reflected light is incident on the lunar surface, and the moon reflected back to Earth. So if you're on the dark side, if you're the night time, if your time is in the night time, you might see some Earth sign. You might see some Earth sign. So it occurs predominantly during new moon. You can also see it in other lunar phases. So here is a picture of the moon not experiencing earth shine and the moon experiencing earth shine. So you must have heard about the blue moon. Blue moon, there are a lot of names given to the moon, and one of them is the blue moon. And some people freak out. They say, "Oh, the moon is blue." No, none of these things are real. All this pink moon, wolf moon, blue moon, they are not real. They are not intrinsic to the moon. They represent some traditional cultures. So, so traditionally, the blue moon is defined as the second full moon in a calendar year. It happens roughly every 2.5 years. So that is why people call it once in a blue moon. Okay, so it means that something is very rare. But assuming that moon actually starts shining in blue color, it is not something that is intrinsic to it. It means that probably something is in our atmosphere, just like our atmosphere is reflecting. It's bluish during the daytime because it is because of the dust in the atmosphere that is scattering colors of light, really scattering. So here are the monthly names of different full moons per month. And these things are drawn from different cultures in Native America, Europe, and other countries. So on January, we call it the wolf moon. I've heard about the wolf moon. January, it doesn't mean that the moon is now wolfy or looking like a wolf. It's just some kind of some kind of tradition. Okay. Then we have a snow moon on February. We have a worm moon on March. We have a pink moon on we have big moon on April. We have a flower moon on May. We have strawberry moon on June. We have buck moon on July. We have sturgeon moon on August. We have harvest moon on October. We have hunter moon. We have harvest moon on September. We have hunter moons on October. We have uh, beaver moon on November. We have cold moon on December. So thank you for paying attention to this lecture to the lecture series. And if you have any question, please drop your question in the comment section. We're going to respond. All right. Thank you.